today you are welcome to this class. This is FTH 303, tensor, vector and tensor analysis. Today we'll be looking at gradients, vector differentiation, continuation, gradients, divergence, and the curve. So let me quickly share my screen. From then we continue. So if you have any question, feel free to ask your question, coming back where it's not clear. So let's look at this example. Number one example for today, if A is equals to 5 t squared I plus tj minus tk, t raised to power 3k, and B is equals to sine ti minus cos tj. Find A d dt of A dot B, B d dt of A cross B, C d dt of A dot A. Can we solve this problem by ourselves?
Yes, sir.
If you can solve it, raise up your hand, please. Let me just see your hands before. I don't want to assume. Only one person. Okay, let's quickly solve it. There are two ways of solving it, of solving this particular problem. And the first one is talking about, the first part of solving this problem is talking about it will be talking about differentiating it dot by dot, or at times the other way of solving it is, first of all, do like where you have A dot A, first of all, do A dot A separately, then differentiate. Or you differentiate them one after the other. Let's solve it. Let me just give us an example solution. Now for d dt of A dot B is the same thing as A, according to the definite formula we have in the previous video, t plus dA over dt dot B. So is it that we use this method, or we use A dot B, get your A dot B, answer, then differentiate the A dot B. So you can see the two ways. Like I told you earlier on, you need to sharpen your differentiation skill. But let me use the first one for the purpose of this class. Let me use the first one. So the first thing is, let's differentiate the A dt. Let's differentiate the A dt. Go to the A. So that is, differentiate A with respect to t. We are differentiating 5t squared. We have it to be, it will be 10t. I hope all of us can do that.
Yes, sir.
Plus,
Yes, sir.
when you differentiate t only, what do you have?
1.
You have 1. 1 multiplied by j, it turns to j.
Okay.
Then you have to differentiate t cubed. We have going to have 3t squared k. So let's do the same thing to dB dt. dB dt, we have to differentiate it before we start multiplying, so that it will be easier for us to pick. So when you differentiate sine, what do you have? Sine t, you have what? Cos t I minus, when you differentiate cos t, what do you have? Negative sine t j. So the final answer will be cos t I plus sine t j. Are you getting it now? So we have this. Now we can now go ahead. We know our A. So let's substitute it now. Our A now, we are substituting. Let's call this one equation 1. Then equation 1 becomes we know A to be, let's write A. Our A is what? Can you call it for me?
Our A is 10t.
Nope.
Okay,
8.
the original A itself, 5t squared.
5t squared I plus
I
tj
plus tj minus t cubed k.
minus t cubed k. Yes, thank you. Dot dB dt. Remember dB dt? Cos t.
That's cos t
plus
cos t I plus sine tj.
tj. Plus, don't forget, the A dt. The A
And that
dt is
will
what?
be 10ti
10ti
plus j
plus j
minus 3t squared
minus
k
3t squared k. Dot
b. And that b is sine ti minus cos tj.
sin ti minus cos tj. So let's make the dots. Remember, from the knowledge of dots, you use the coordinates to match each of them, right? Let I multiply by I, let j multiply by j, and let k multiply by k. So I to I now, we have what? 5t squared. You know, I times I is 1, right? So you have nothing to lose. Just put cos t. Then j to j plus t sine t. Then you see the first one that we are dealing with. Here we have k. Here is 0. So 0 multiplied by anything is 0. So you don't bother yourself. You continue with the next one. Plus ten t sine t minus cos t. Then k multiplied by k is also 0. So we have sine t, cos t, and so you can agree with me that if I said cos t is common here, cos t is here, cos t is here, I can take it out by saying, since this is 5t squared, we can't add it together. So we can just say 5t squared minus 1 cos t. Then plus, we have 1t here, we have 10t here, 11t sine t. So that is the answer for this. So I believe we can use Can we continue? Any question, please?
So how do you get that -1, sir?
Which one?
5t squared minus 1.
So you have here, you agree with me that it's 5t squared, right?
Yes, sir. Yes, sir.
Then there is a 1 here. 1 cos t is here. But we don't write 1 cos t. Because if I open the bracket now, I will get negative cos t back, right?
Yes, sir.
Then I will also get my 5t squared back. So that is how I factorize just a kind of what is common to them, factor it out. Is that okay by you?
Yes, sir. Yes, sir.
Number 2 now, we have under, okay, we have B, number B.
Sir.
Yes.
Sir, can we collect the like times here, sir?
Where?
In that cost t, can we collect
That's
the
what
like
I
times?
did.
Okay.
The light time is cos t. I take it out.
I
Then
understand.
I now write, did you get it now?
I get it now. I get it now.
A cross B is equals to A cross dB dt plus the A dt cross B. You know that when you are solving a cross problem, you need to put it in this shape, put it in matrix form. So if you look at the A, we are looking at A now. What is our A, please? Anybody? I for A is what? I for J is what?
1. That's T.
I'm just T, that's T, right?
Yes, sir.
What is K?
T raised to power 3
Minus T.
minus T raised to power 3.
Then let's go to the B dt. What is I for the B dt? Go to the, you didn't write.
Cos T.
Is what?
Cos
Cos
T.
T. Thank you. Then what is J? And K is 0.
Yes.
Plus I, J, K. What is the A dt? Then T 1 minus 3t squared sine t minus cos t is 0. Are you there, guys?
Yes, sir.
Yes, sir.
Okay. So what do we need to do at this point? Anybody?
Fine, sir. We find the determinants of both sides.
Okay. Okay, let's take them one after the other. So then we move on. First thing you need to do here is you remember the way you did the determinants in in algebra. So we take I. Let me just try and break it here. When you are taking this place, everything here will paralyze. Here, the first row will paralyze, the first column will paralyze, first row will also paralyze. So you will remain with what? Please, if it's not clear to you, let me know at this, because I will only take my time on this, because the rest will not be that difficult. This particular column will be paralyzed. This row will also paralyze. You are left with T minus T cube sine T 0. Don't forget is I. But the next thing will be what?
Minus J.
Minus J. Remember this side, plus, minus, plus, right? Minus J. So you can remove this one. This one will also be paralyzed now, the second column. First row will still be affected. So everything here will paralyze, this one will low. So you have what? 5t squared cos t negative t cube 0 plus k. So the third column will be paralyzed and the first row will also paralyze. You have what? 5t squared cos t sine t. So plus, or should we do it one after the other?
Yes, sir.
Okay, let's finish this one, then we'll come to the other matrix. So when you remember this multiplied by this, then minus this. So this is first, this is second. So you can see it will help you by then. So you have it to be I. Let's open the bracket. 0 multiplied by t is 0, minus t multiplied by negative this, you have minus t squared sine t. This is all your I. Minus j, you do the same thing. 0 minus
Sir, the first one
t
is
cube.
Sir, the first one is TQ.
Thank you.
The I part, Professor.
So it's the same TQ here. So 0 minus this, minus t cube cos t plus k. 5t squared sine t minus t minus t
Cos T.
cos t. Thank you. So we can now begin to write it out. We have t cube, positive, negative times negative, positive, sine t I, minus, don't forget, negative times negative, positive is minus t cube
Q cos t.
cos t j, then you have it to be plus, you can put those one in the brackets, everything, because there's nothing you can just leave them the way they are. At the end of the day, some will cancel out when it gets to that point. In brackets, 5t squared sine t minus t cos t k. So that's what we have for first matrix. Second matrix, we do the same thing to second matrix. So you guys will be, I can just take my time and write it out by myself, but let's just do it together. Okay, let me just say plus. I hope you are following now.
Yes, sir.
So this plus is the same thing as this one at the middle here. So let me remove this arrow. It's the same thing as this one. So if I cancel this one, then this one also go. I will left with 1, 0. Can you call it, please? 1, 0 minus 3 squared minus cos c. Then negative j, you have 10t minus t squared sine t 0. Positive k, you have 1, 0 t 1 sine t cos t. So when you open the bracket, you have I will be what? 0 minus 3t squared. This is positive rather. You don't need any minus because negative times negative, positive straight. So you have 3t squared cos t minus j, 0 minus 3t squared sine t minus, there's a plus k in brackets, negative 10t cos t minus sine t. So we have to add the two together, this and this together. So if you are to add them together, but we can also open the bracket for this before then. So here we have negative 3t squared cos t I minus 3t squared
Sine tj
sine tj, thank you. Yes.
minus 10t cos t minus sine tk.
Okay, minus 10t. Okay, just give me 1 minute. Let me Hello, can we there?
Yeah, we are there, sir.
Sorry for the interruption.
No
Let's
problem, sir.
continue. So let me quickly finish this question. So where we are now is just to try as much as possible to continue from here. Open the bracket. We're trying to open the bracket for this particular one. We are in J already. We need to resolve the K. Factorize in the K. You see, you can factorize the negative out by saying 10t cos t plus sine t k. Any question on that?
So I think it's minus sine theta.
No,
Yes,
he has
I
already
know.
factorized negative.
I've already taken the negative out. So when you open the bracket, it will still give you minus.
Okay, okay.
Do you agree?
Yes, sir. Yes, sir.
So now, how do we now add the two together? Based on the law, the equation star and equation star star, that is, add equation star and star star. So what do we have? That means I will go to I. Are you getting me? Then J will go to J, then K will add to K. So let's go ahead and do that. So you are going to have sine t minus 3 square 2 cos ti minus 3 cos 3 cos t plus 3 square sine t j plus 5t squared sine t minus 11t cos t minus sine t k. So this is what you are going to have if you do it very well. Any question on that? So should I continue, please?
Yes, sir.
Yes, sir.
Okay, now let's look at the C. The C aspect of it, you should be able to do the C. It said d of dt, it said a dot a, which is the same thing as a dot the a dt plus.
Sir, is that where you are going to end the B?
Yes, that's what they asked you to do, except if you can simplify it further.
Okay.
Are you getting it now?
Yes, sir.
Sir,
Yes.
can we be asked to do the double differentiation? In case
No,
we're asked to do double differentiation.
we are going there.
Okay, sir.
These are the things we are going to do today.
Okay, sir.
So we have it to be, this particular one will give you 2a dA dot dA dt. So you know A already. Our A is what? Let's say 2 is here. Bring A here, 5t squared I
Plus 2k
plus tj
minus t cube k.
minus t cube k dot 10t I plus j minus 3
minus 3t square k.
square k. Open the bracket for this before you do the dots.
We have 10t squared plus 2tj
yes
plus 2t cube k.
dot
10ti plus j minus 3t square k.
So now we can do the dot now by multiplying t and t, right? You have it to be 10 times 10.
100.
You remember that you have to add the power of the t. Do you agree with me? Do you agree?
Okay, sir.
Don't
Yes,
say,
yes.
okay, do you
Yes,
agree?
yes, yes.
A raised to power x multiplied by a
Yeah.
raised to power y is the same thing as a raised to power s plus y. That is what I use that gave us this. That is, you have t squared multiplied by t raised to power 1 is the same thing as t raised to power 3. That is what you see there. Is that okay?
Yes, sir.
So let's continue, please. So the next answer will be what for k? So you remember I dot I is already become 1. So we continue will be 2
tj
2t and plus what?
plus 6t raised to power 5k
60.
raised to power 5k.
You don't need k again. Don't forget. K
Alright,
multiplied by k will be
k will be
1. So any question? So let's look at this that have, that's question 1. Question 2, let's look at this. If a is equals to 2, we are going to the partial derivative now. Minus x is to power 4 I plus exponential xy minus y sine x j plus s squared cos y k. So I will take my time to explain the first derivative. They now ask us to find the a, the t, the x, find the a, the x, find the a, the y, find the square a, the s squared, the square a, the y squared, the square a, the x, the y. Then they ask you to find the square a, the y, the x. Okay, let's solve them one by one. So you have to be careful here when you are asked to find something like this. The a, the s is the same thing as d dx of 2s squared y minus x is to the power 4i plus d dx of e raised to the power xy minus y sine x j plus d dx of x squared cos y k. So in this case now, what we need to do is just to differentiate with respect to x, all these functions with respect to x. Anywhere you see y, it simply means the y will be constant. Are you getting my point now?
Yes,
Yes,
sir.
sir.
Y will remain constant while you differentiate x. Now, but let me quickly say this. If you are asked to differentiate, now for us to differentiate ddx of exponential xy, you must be smart in this case. All you need to do is just to do like this. ddx of xy. Are you getting it?
Yes, sir.
You bring the power down, you differentiate the power, you remain this one. How do I differentiate the power now? Remember, if the power is saying you should differentiate with respect to y, you use the y. But now it's the x. So the answer will be what?
That would be the y exponential x.
Y
X.
exponential xy. That's all. Because when you differentiate x, x will be 1. 1 multiplied by y. Y. But assuming is this one is raised to power 2, you differentiate this one, will now be 2xy. But now it's not 2, it's just ordinary y. I'm just using this period to explain it. If this one changes to y now, this one will be what? X. Are you following me?
Yes, sir.
Yes, sir.
Okay. Let me clean this. So, Tayo, are you still there? Okay, let's continue. If you differentiate this one, what do you have? The first I. We are going to have 4xy.
4xy minus 4x raised by 3.
Thank you. Minus 4x raised to power 3. This is I. Plus
Y exponential xy.
Y exponential xy. So what do you have? Minus y cos x.
Okay.
Remember, when you differentiate sin x, you have cos x. When you differentiate cos x, you have negative.
Minus
So
sin x.
take note of that. Then plus differentiate x in this case. You have what? 2x cos yk. So that is what they ask you to do. So then let's move on for the y.
Sir.
Yes.
Sir. So we will not differentiate that cost y because it has a we are
Y.
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 Okay.
Exactly.
Okay. Thank you, sir.
Because he has y, you treat them as a constant. So let's look at the second one, the y, the a, that a, that y is the same thing as, we focus on the y, we have it d dy in brackets 2x squared
2x y
s4
minus x raised by 4
plus dy
plus
dy.
y d over the y exponential xy minus y sin x j plus d dy again. Then x squared cos y.
So when you differentiate this one now, don't forget, you are to hold s constant.
X.
So if I'm to differentiate this one now, I will have 2x squared. Because when you differentiate y is 1, so there's nothing you do, you leave it. Now, when you differentiate x here, remember, you can only hold them cost. When you differentiate constant, what do you have? 0. You can only have constant in this place. Okay. You can only have constant this particular constant now, when you differentiate, when you differentiate y, that is 1, right?
Yes, sir.
Minus, if you differentiate x, what do you have? 0.
0.
Because we are differentiating with respect to y, not with respect to x. Let me put it this way. I. So that plus, when you now differentiate this with respect to y, what do you have?
X. That would be
exponential
x
sy minus sine x. Why are we differentiating? Remember, you can only say sine x because
there's no y at the back of
y is no. When you differentiate y here, what do you have? 1 sine x. Is because they are together. That's why everything has not turned to 0.
Okay.
When they are together, you maintain them. But when the y or x alone and you are differentiating with the opposite, it will turn to 0 automatically. Plus, now let's differentiate this one. When you differentiate cos y with respect to y, what do you have? You turn to minus s squared sine y. You put the k. So I can rewrite this one by saying my dA dy is equals to 2s squared I plus exponential sy minus sine sj minus s squared sine yk. Is that okay?
Yes, sir.
Okay. So now you go ahead, you now differentiate. We've done 1 and 2. We need the square. Let's look at this. The square a the square a the s squared. Remember, we already differentiated the x. The a, the x, we've differentiated. So you can differentiate the second time. That's the meaning. Meaning d, the x of the a, the x. That's the meaning of this. So anywhere you see the x, what's the value we have for the x the other time? You just say d, the x of I. Our I then is 4xy minus 4s3
plus y exponential xy
plus d
y
dx of what?
y
Of
exponential
y
xy
exponential xy, thank you, minus y cos
j
xj. Then the next
plus d the x again. Then we have 2x cos y k.
cos y. Okay. So we cannot differentiate it again. Hold all the y constants. Y at this point, they are constant. Don't forget. So, Samuel, Ola, are you there?
Yes, sir. Yes, sir.
I hope you are getting it.
Yes, sir.
Okay. Now let's differentiate x now. Give me the differentiation of the I. Y side, counselor will give me the differentiation of J. You give me differentiation of I. Go ahead.
4x.
No. 4y. Because
4y.
x
Okay,
will have
4y.
turns to 1 when you differentiate it.
Yes, sir.
4y minus what?
12x raised to power 2.
Thank you. I. Next, counselor.
Okay. I'm gonna try x. I'm correct. Sorry. xy square exponential xy
Exponential No.
No. Wow.
Look at it. You are differentiating with respect to x. So you have y squared
Okay.
exponential x y.
Why?
Remember, x will have turned to 1 again. Is that okay now?
Yes, sir. Thank you, sir.
Okay. When you differentiate cos, what do you have?
That would be plus
Plus y
sine
x j. So now let's differentiate k with respect to x. That's the simplest one. 2 cos what?
y.
K. That's all. So that's what they ask you to do. So you can do the same thing for the rest. Don't let me waste more. Which one do you think is difficult? Okay, let me do, you can do y squared by yourself.
Yes, sir.
Right?
Yes, sir.
The last two.
The last two is the same. I will do one of them. This square a dx dy is the same thing as d dx of the a dy. You know we have the a dy.
Okay.
What happened?
No, I saw a question like this actually in the past question, but in that case, you had this square a over the x squared dy. So I was actually confused on how do I go about it. But with this explanation,
so you break, that's the essence of this facilitation class. You break it down, d dx in bracket. Can you send me those past questions?
Okay, sir, no problem, sir. I'll do that immediately after the class.
So you have you have the y already, which is this. We have the y. Let me pick another pen. We have the y. This is our dy. So all we need to do is use this to differentiate with respect to x, because you already have the y. So it's not hard the way you think. So let's look at this now. It's going to be d dx of, what is 2i? We have 2x squared I plus d dx. I'm substituting the a dy now.
That's x exponential xy
Thank you.
minus sine x
Sine x
j
j plus d dx
x squared sine y
is it minus?
minus x squared sine y
Minus
x squared sine y.
sine y. Okay, so it is simple. What they ask us to do now is, let's differentiate this with respect to x. I have 4xi plus, now if I'm differentiating this with respect to y, with x, what do I get? First one,
4x I plus, okay.
this one, j.
Okay, j will be what? Okay, x, sorry. So I thought we are changing to related to x.
You said?
Okay, x square y. X, y, and one of the y will go. Okay, I'm consistent.
Do you agree? Remember I said x. They are now bringing another x, y. You want to differentiate them. So it simply means this with respect to x. When you differentiate x here, you turn to 1. 1 multiplied by y, y. You have xy, exponential xy. That's all. Okay. This is what you have. Can I clean it? So minus, when you differentiate cos, now you need to be careful here. That reminds me, remember, you are differentiating with respect to x. In this case, you are going to apply product rule. Are you getting it?
Yes, sir.
That is, you hold one constant, you differentiate one. I've already differentiated the exponential. I need to hold this one constant, and I now hold s constant. So I'm differentiating with respect to, let me start all over. Now you have x exponential x, y. We have to differentiate it with the x, ddx, right? This is my u, this is my v. Are you following me now? So if the differentiation for du, dx plus dv, dx, we have v du dx and u dv dx, right? Hello?
Yes, sir. Yeah.
So when you said let our u, our du ds is equals to what? 1. Our dv ds is equals to what? When you differentiate the v, you have it to be y exponential x, y. Are you following me now? Now, I'm just digress here, trying to sort, oh, sorry. I'm just trying to sort this particular gentleman. So what I'm going to have here is substitute into this equation. What is my v? My v is exponential xy. Are you following? What is my du? My du is what? 1. Plus u is what? X. What is my dv du? Is y exponential sy. So my final answer will be exponential sy plus xy exponential sy. So this is what I will put to replace this particular one. That's why I said product rule. I hope I'm communicating.
Yes, sir.
So it's going to be xy plus xy exponential sy k. J, sorry. Then we need to do the one of k. Minus k. When you differentiate k, what do you have? 2s sine y k. So that
Sir,
is, yes.
Sorry, please, can you go back a little, up a little, go up a little, sir? Wait, okay, yeah. We're differentiating d over the x, right? Of x exponential xy minus sine x. But at the other part, there is no cos. Does it matter? As in,
Oh,
we
it
need to change the
matters.
sign
So
to cos.
that's
We need to
omission, please.
change the sign to cos.
No, that's omission. Let's write it. Sorry. So when you differentiate, thank you for that observation. When you differentiate sine x, what do you have?
That's cos x.
Cos sj. Thank you. So the next one, so that's what they asked us to calculate, actually. So you can use the same method to solve this one. D square A dy dx, meaning the one in front will be your target. So it's going to be, what? The square A, it will be D, you will get the same thing, but
Okay, d dy,
the D dy,
then
the A,
a
yes.
dx.
So go and bring the x, differentiate it. You will have the same answer. your answer will be the same. No, it's immaterial. The order is immaterial, they are the same. But try and do it to get whether they are the same or not. Any question on that? Silence means no question. Okay.
Sir,
Yes.
with the one I asked earlier now, like in the case whereby it was like it is d square a over d square y, the y square dx. In that case, would it be that we just have d over the y square?
Let me write it out.
Okay.
D square a
over the y square dx.
Now, there is tendency that you've done something on this before, so you can it will not be probably you've done this dy squared multiplied by dA dx. Are you getting it?
Yes,
or
sir.
You first of all solve this one by yourself before you now use this one, differentiate it again. Either of the two. Yes.
Okay. So what we'll just do is, in that case, it will be like we'll do the a over the y, then we'll do the a over the y again, sir.
Yes,
And
that's
we'll
why
do
you
the a
differentiate
over the
it
x.
twice. Then
Okay.
after you differentiate it twice, you can now do the one of the x again.
Okay,
You
sir.
now
Thank you very much.
differentiate the same thing with respect to x. This is what I'm saying. D dy. Are you getting it?
Yes, sir.
Or D, okay, you can do it this way. So you have the A already, meaning you have you have the A already.
Yes, sir.
Over the Y. So you differentiate it again, it will give you the square A dy square. Now, the same the square A dy square, you can now differentiate it with respect to x.
X. Thank you, sir.
That would now lead you to this one. Okay, let's continue. Please, all these things are very key. And I didn't know that it came out in your exam. I'm just doing my own, the necessary thing that I know, that I think you need to know. That's what I'm solving. So let's look at number 3. If you have the phi of x, y, z to be equal to xy squared z, and a is equals to xzi minus x square y, s square j plus y square k, then I said find, I'm laughing because it's the same question you asked me now. Find the cube of the x squared dz of phi a at the point two minus 1, 1. So what you need to do is, first of all, resolve the a, resolve this one. The solution now begin. Phi a is equals to what? Xy squared z into, multiply by a now, right? X zi minus xy squared j plus y z squared k. So that is, this particular one will multiply each of the components. Remember, this does not have the first, this particular one, let me highlight this. This particular gentleman does not have a IJK, but is just there as a constant, like 2. 2 is multiplying all through. That's what we are doing now. So don't say it must have I. No, you don't need I in this case. So x multiplied by x, you have x squared.
Okay.
Y there's no y there, y squared. Then z multiplied by z, z
Okay.
squared I. He has already transformed it. Minus
X squared,
s squared,
y raised to power 4, z, j,
okay, plus
x, y raised to power 3, z raised to power 3, k.
good. So we have phi a already now. So this is what we are going to be differentiating one after the other. So first of all, differentiate with respect to z. D dz of phi a is equals to what? So we have d dz of phi x squared y squared z squared I minus x squared y4 zj plus xy cubed z3k. So it's going to be
2,
with z. Don't forget, have z
yes.
in mind,
Yes, sir.
not s.
2,
You have
2x
2
squared,
s
x
squared
squared, y squared, z, I, minus
minus
x squared, y raised to power 4, j, plus 3x, y raised to power 3z squared, k.
good. So that's what we have. Now, the second thing you need to do is you take it one after the other, the square, the x, the z now of phi a. Remember, this is still what we are doing, the one we are doing now. So you differentiate this one. Let me call this one equation 1. Differentiate that equation 1 with respect to x now.
Sir,
Yes.
on that second one where we have x squared y raised to power 4 zj, why don't we differentiate that x?
Remember what you are asked to do. The what?
The z.
Z. Okay.
Are you getting it now?
Okay. Yes, sir.
So now we are moving towards x. Follow the instruction. Follow the question. Don't do what you think. Do what the examiner asks you to do. So let's go ahead. Are you okay now?
Yes, sir. Yes, sir.
Thank you for that question. So let's differentiate with respect to x. You have what now? 4s y squared zi. Differentiate this one too. Minus
2x, that's minus 2x,
x
y raised to power 4,
plus
that's 3, y raised to power 3. Okay, no. Yes.
are you getting it now?
Yes, sir.
Sam, are you okay now?
Yes, sir. Yes, sir.
Okay, let's continue. The square. Now, you have to be careful at this point. So this is the third time of d of phi a divided by dx squared dz. Are you seeing the way we are solving it step by step? So for us to differentiate this one again with respect to z,
Comes 4y
Wait,
Square.
let me just write it again so that people, I think I will need to write something here. I'll just do it this way. D dx of this 2x squared y squared z I minus s squared y 4j plus 3s y3 z squared k. So you know that is the one that we did that. So this one will be d dz dx again of 4x y squared z minus 2xy 4j plus 3y cube
Z square K.
z square k. So now if you differentiate this one, what do you have?
4y square Z I
4y squared zi
minus 2y raised to power 4j.
minus 2y raised to power 4j.
We can't differentiate that one because there's no x in the constant.
Just put 0 k.
0, sir.
Yes, they are all 0 there. So we might not write it, we can still write it. It doesn't, nobody would penalize you for that. Remember from the question, you are given a point. All these points are very key. So it simply means at this point is, you just recall, at point s equals to what?
2
Y equals to?
minus 1
And z equals to?
1.
So what happened to this? You have 4 into negative 1 squared,
Yeah.
z1
Minus 2 into bracket 1 is power 4.
I minus 2 into negative 1 4 j. So you have what? 4i minus 2j. Any question?
No one at all, sir. Thank you, sir.
So when you are given this, these are the things they ask you to solve from here. We have, I know you have a lot of questions on this, right? Any confirmation? Okay, let's move on to another interesting topic. The vector differential operator. This is the beginning of the course. Are you getting me now? We call it del, is in this form. And the same del is equivalent to are we there?
Yes, sir.
D dx plus d dy j plus d dz k, which is the same thing, is the equivalent to d, or you can write it I d dx plus j d dy plus k d dz. These are the vector operator. All these processes are different properties to analyze to those in ordinary vector. It is also useful to define 3 quantities which arise in practical application are known as gradients, the divergence, and the core. Remember I mentioned it, that is the gradients, the divergence, and the core. Let me just put it there like this. Take note of that. So let's pick one after the other, the gradients. We start with the gradients. I will a little bit fast now. The gradients says, I will not give you too much definition. You have it in your notebook, but for the purpose of the video and any other person that can, let's look at it. Let's phi equal of s comma y be defined and differentiable at each point of s comma y comma z in a certain region of space. That is, our phi, that is, the phi defines a differentiable scalar field. A differentiable scalar field. Then the gradients, then the gradients of phi is written in this form, or grad phi, which is defined as, when you define it in this way, same thing as d ds I plus d dy j plus d dz k. Everything multiplied by phi, which is the same thing as d phi dx I plus the phi dy j plus the phi dz k. Note that this phi, the gradient phi is defined a vector field. So you define a vector field. So we have different examples. Well, with the time now, I don't think, I think I will just give us some we've saw some example already, but I'm just looking at the time and see what we can also cover with the example of the gradient. Okay, let me give us this example. Let's look at this together. Example 1, let's say example 1 for the gradient. If we've solved it together anyway, phi of s comma y comma z equals to 3x squared y minus y cubed z squared. That's a find del of grad of phi at the point, like the question we solved, actually we are in line with, is the same question, like the way we solved that question, but the difference between them, you will see it now, at the point 1, comma, minus 2, comma, minus 1. So now this one is like this, equals to, write the formula, the del out. If you are writing exam, please don't forget this. Don't just jump into it because you know it, or you have to follow it like this. Remember, you are not doing objective. So now we have this, which is our del. Then what is our grad? Our phi is what? 3x squared y minus y cubed z squared. Are we there?
Yes, sir.
Okay. Now let's continue. So it simply means that each of these 3x squared y minus y cubed z squared will be, you will put them there one after their phi. It will belong to the phi, like we did the other time. It's going to be, this one will be I can place my I in front by doing like this. ddx of everything 3x squared. Let me just clean this one. 3x squared y minus y cubed z squared plus dy. You can see the difference now. J into 3x squared y minus y cubed z squared plus k dx dy. The z is going to be 3x squared y minus y cubed dz. So let's do the operation one after the other. Differentiate this one with respect to x. You differentiate this one with respect to y. You differentiate this one with respect to z. You can see the difference. Are we there? Hello?
Yes, sir. That would
Can you
be
see
6x.
can we see the difference?
Yes, sir. Yes, sir. Yes, sir.
Okay. Go ahead. When you differentiate this one, what do you have?
We have 6x
6x, thank you.
minus 0.
6xy. Because y is a constant with, it's like 3. Are you getting it now?
Yes, sir.
Plus, the rest will be 0 because we are differentiating with respect to x. Plus, let's differentiate this one.
3x squared minus
3x squared minus 3y squared z.
3y squared z squared.
Because we are differentiating here with respect to y. Plus k. We are differentiating k with respect to z. So you
That
have
will be
zeros here.
minus 2y cubed z.
That's it. So at the end of the day, you have 6xyi plus 3x squared minus 3y squared z squared j
Minus 2y
minus
cubed
2y
z.
cubed. So now we have points. Substitute your point. What is your point? At point yes,
1 minus
x
2 minus
equals to
1.
1,
Y
y
equals
equals to,
2
and z equals to.
minus 1.
So let's put it there.
That's 6 into bracket 1 divided by minus 2. I. Okay, no more. One square, not minus 1. Three into bracket minus 2 square minus 1 square.
Okay, let's swap it. What do we have?
Minus 12i.
This is 3.
3. 3
This is
minus
negative 4, which is
12.
positive 4.
Okay, yes. Minus
Everything minus what?
12. So is it going to be minus 12 because we have minus 1 at the back again?
So
Okay.
it will be,
It should be plus 12.
remember that this is, yes, it will be plus 12.
Plus 12.
Oh, there is,
Yes, there is minus 1 at the back.
so this one is square too.
Okay, is this square too? Okay.
Yes, check it.
Oh, yes, yes, I think so.
So minus what? Again, this is 80. This is 8.
Minus 8. That's 2 times
Minus 8 times minus 1.
That's plus 8.
No, check it again.
No, you said minus 8 times minus 1.
No. Minus 8 times minus 8 times minus 1, minus 8. Plus 8, right?
Yes.
Plus 8 times 2, 16. Minus
That's
16.
Minus 16. Okay.
So at the end of the day, you have
Minus 12i
minus 12i
minus 9j
9j minus 16.
minus 16k.
So that's what it has to calculate. I will snap this one to you guys to check. But because of our time, let's quickly go to the core. And I have another one on direction. So I'll snap this one to you after the class. I have one on direction, which you guys need to know. Or are we tired?
No, sir.
Okay. Let's check this one. find the direction or directional derivative of phi equals to s squared y z plus 4x z cubed squared at 1 minus 2 minus 1 in the direction in the direction 2i minus j minus 2k. So for us to find this, we know is del phi is equals to del, what is our phi? S squared yz plus 4xz squared so we can solve it. So if you want to solve this one, it's going to be I dx of the whole thing plus j dz dy plus k dz s squared yz plus 4x z squared. So we need to solve this one now. Differentiate this with respect to x. I have 2x yz plus 4 z squared. This is I. With respect to y, you have s squared z k with j. With respect to z again, you have xy squared plus 4x. Now, when you differentiate this one, you have 8xz. Any question? Any question? Are we together?
Yes, sir.
Yes, sir.
Any question? So,
Sir.
yes. If you substitute it very well, you are going to have 8i minus j minus 10k. That is at s equals to 1, y equals to minus 2, and z equals to negative 1. So you have this. So the unit, the question continues that the unit vector in the direction of 2i minus 2j minus 2k is, you remember the formula for unit, A equals to 2i minus 2j minus 2k divided by square root of, remember, x squared plus y squared plus z squared. Revise your notes. It's going to be over squared plus -1 squared. I'm using the coefficient of each of them, plus -2 squared. If you do that, you have, very well, you have 2i minus j minus 2k over 3. Because this is 9, square root of 9 is 3. So at the end of, you have 2i, 2 over 3i minus 1 over 3j minus 2 over 3k. Two over 3k. So that's what we are. They now said we should find then the required directional derivative. Is del phi multiplied by a. We already have our a. This is our a that we calculated the other time. So it's going to be this dot this. So 8i, don't forget, we have our phi here. We have it from here, which is same thing as phi over this, del over phi, del multiplied by phi. Excuse me. So we have minus j minus 10k dot 2 over 3i minus 1 over 3j minus 2 over 3k. So let I goes to I, let j goes to j, k goes to k. So I to I, that is this to this, then this to this, then this to this. So you are going to have it this way. I to I, we have 16 over 2 over 3.
Over 3i.
You will not have I again, don't forget.
Okay, yes, I becomes 1.
Yes, plus 1 all over 3 plus 20 over 3. Because this is negative times negative, it turns to positive. Negative times negative, it turns to positive. So at the end of the day, if you solve it very well, you have 37 over 3.
37 over 3.
So that's what they ask you to calculate. So let's
So
look
can we
at,
further divide it and leave it as like an improper fraction?
you can leave it this way or use your calculator to punch the final answer. It depends on you.
Okay.
Any question?
Yes, sir.
So which one is proper? Should we leave it in proper fraction or mixed fraction or in decimal?
Anyone. Just make sure once you are calculating everything like this, just put it in fraction and put in brackets, put the or just write the decimal point so that anyone the examiner provided for the person.
There was a question like this with TME actually.
Eh? You said?
There was a question like this in the TME.
Really?
Yes, but the options there were actually totally wrong.
I don't know. Okay. God will help you guys.
Amen.
Let's continue. The divergence. I'll just solve one question on this. Then we'll go to the core. then we call it a day. So the divergence is just if A is equals to S, all you need is just differentiation. If you know how to differentiate, you can pass this course excellently. You don't need any stress. Differentiation, integration, because we are moving towards integration now. So they ask us to find, for divergence, it said find del dot A or div A. They put this way. At the point 1, -1, 1. So for div A, we have this div solution now. We have div dot A to be d dx I plus d dy j plus d dz k dot s square z I minus 2y3 z squared j minus, this is too big, let me just reduce the size. Okay, dot s squared zi minus 2y3 z squared plus xy squared xy squared
ZK. Okay.
zk. So all you need to do is substitute. Now look at this one. Look at the difference between them. The one of gradients, you have only one without coordinates, without any ijk.
Okay.
But in this one, in the divergence, you have I to I, j to j,
Okay.
k to k. Can you get the difference? So you are now going to be d dx. What is the I? S squared zi. Can you see? Plus d dy in brackets. You don't need I again, sorry. Don't forget.
Yes.
I will have nullified the I will be I squared. I squared is equal to 1. You remember?
Yes, sir.
J squared is equal to 1.
1.
K squared is equal to 1. Then plus d dz. What is the d dz?
XY square Z.
Y squared. So you don't need any direction, any I, j, k here. Now let's differentiate this one. You have 2x
Z
z. Now you
minus
have negative here, negative.
6y squared
6y squared z squared
Z square
plus
XY squared.
xy squared. And the point is what?
1 minus 1, 1. X is 1, y is minus 1, Z is 1.
So you have Z, right? What is Z?
1.
So when you substitute it, what do you have?
One.
So you have 2.
Minus 1 square. The last one is minus 1 square.
You have 2 minus 6 plus 1 equals to minus 3. Any question?
None, sir.
Okay. There's one I want you to go and solve by yourself. I will just explain. Assignments. Given that phi equals to 2x cubed y squared z raised to the power 4, find a. The phi. B. Show that y del multiplied by del phi is equals to del square phi, where del phi, del squared, where del square phi, or where del square is equivalent to the square or the s squared plus the square, the y squared, so we have plus the square, the z squared. So we call this one denote Laplacian from the word Laplace. Denotes the Laplacian operator. The Laplacian operator. So then we can easily solve this one. How do we solve that? A, all you need to do is find your del phi. You do it.
You do 5. You do the del again.
I, the S, this. Put everything there. Plus d, j, d, the y. Put everything. Plus k. Put everything. Then you can now find this one. The solution you have here, let's say the solution is this. You now put the solution here again. It will not still be. Remember, the solution you will now have now will contain ijk. You have the solution like this, I.
Yes. We just look for the del again.
Plus k. So by the time you now doing it, multiply by everything, you will now be I to I j to j, you need to differentiate it, and k to k. So by the time you do that, you dot them. That will be your final dot here for A. So the same final dot for A will be, you just want to prove that truly what they want you to prove is the B is the square, the S squared plus the square, the Y squared plus D squared, the Z squared, everything multiplied by 5. That's what they want you to do. Is equals to this. If you can show this one, it's simply you're right. So go and do that. So let's quickly look at the one of core, the core. The core, how do we solve the core when you have the question of this nature? It's always, the core is defined as, anywhere you see this, let's say we have, if V of S, comma Y, comma Z is a differentiable fact, is a differentiable vector field, then the core or rotation, can use rotation of V, can be written as cross V, or you at times call it this, core V or rot V. So they can use anything to define it. Some of this, they can use either of these three to define it. Depend on the books you're using. When you have this cross V, what does it mean? Is D the xi plus D the yj plus D the zk cross V1i plus V2j plus V3k. So if I have this, how do I do that? Anytime you see cross, you remember the matrix should come to our mind, the determinants, I, J, K. That's what they are saying. So we just put this one, D the X, D the Y, D the Z. And you have V1, V2, V3. So how do we resolve this one? The way we solved the other time, we take I. When you take I, everything here will disappear. This one will go. You have D dy over V2, then D dz over V3. And as J, you have D dx D dx V1 D dz V3. Plus plus k. This one will cancel this, remain d dx v1 d dy v2 k. So we move on. All you need to do is just to cross multiply. The first one will go to this dv3 over dy. Are you following me now? Minus dv2 over dz I minus ds dv3, sorry, dx minus dv1 dz. Please don't make mistakes. J plus dv2 dx minus dv1 dy. Which is what? K. That's all. So the definition is not more than that. So let's just look at one example before we call it a day. There are a lot of definitions on them, but I don't have time for that. If you want to learn more about those formulas, you can look at your notes, your textbook, you see them there. You can also do some little research if you have the time, to solve some of those problems. But let's look at this simple example. Then you can lay your hands on the rest in your book or in the past question and see how you can go about it. Okay, let's look at number one there. It said if A is equals to xz3i minus 2x squared yzk j plus 2yz4k. Find, when you see something like this, they are talking about core A, or they put it there, core A, at the point 1, -1, 1. So like I told you, what they are saying is the solution will be cross A. It simply means d dx I plus d dx d dy j plus d dx the z rather k cross the value, which is xz3 I minus 2x squared yzk plus 2y z raised to power 4k. So I can go ahead and solve the problem by putting it here, I, j, and k. d dx, d dy, d dz. So this one will be what? xz3 minus 2x squared yz, 2yz4. So we can go ahead by saying I. If you want to solve for the I, we have it this one way. This one will go. This will go. and this will follow. So you remain what? D dy minus 2s squared yz d dz 2y z raised to power 4 minus j. Don't forget, this one has plus, minus, plus, right?
Yes, sir.
So this particular one, so we release this one. We pick this one now. So we have what? D dx
X raised to power Z and X Z raised to power 3. D Z 2y Z raised to power 4.
plus
K
k. So you release this one. So you pick this one out.
D dx
Remain what?
D dx X Z raised to power 3. X Z raised to power 3. Then D dy minus 2x squared y z.
Okay, so that's the beauty of this work. You have to do it one after the other. So you pick them I, the I will be, open the big bracket, let them multiply themselves. D, the Y will be for
2y Z raised to power 4
2y z raised to power 4
minus
minus d dz
Z minus 2x squared y
minus 2x, yes, minus j. Although you can put plus there now because of the sign,
fine.
but still maintain your own if you want to maintain this.
Doesn't get confusing.
So you have it to be
D dx 2y raised to power 2y Z raised to power 4 minus D dz x Z raised to power 3 plus D dx minus 2 x squared yz
minus 2
x squared yz minus d dy x Z raised to power 3.
Okay. Now let's now differentiate one after the other.
We have
So
2z raised to power 4.
this one will be what?
2z raised to power 4 minus
2z raised to power 4 minus times
2x
minus plus
plus, yes, plus 2x squared y minus 0 minus 3x Z raised to power z squared plus
plus
minus 4x, yz minus 0.
so at the end of the day, we can rewrite this one by saying I two Z4
Sir,
plus 2S.
in the exam, can we just put the parameters in it this way?
Yes, it's because I'm explaining.
Okay, sir. Minus 4xyz. Where x is 1, y is minus 1, z is 1.
So what do you get?
We have 2 into brackets, 1 raised to power 4 plus 2 into bracket 1 square minus, open the bracket, minus 1 plus 3 into bracket 1 square j minus 4 into bracket 1 minus 1 1. We have 2. That's all. K.
Okay, K is what?
2 minus 2.
Where do you see 2?
No, I meant solving it. That's K. That you've done K already. Okay, K. Okay, K is minus 4.
K is positive 4 because there's negative
4.
here. Here is what?
3. 3J.
So what do you have for the I?
Minus 2. That's 2 minus 2. That's 0.
So the final answer is
3J plus
3J
K. Plus K. Plus 4K.
So on this note, we'll call it a day.